Hey everyone, let's solve Leetcode 141 linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pose is used to denote the index of a node that the tail's next pointer is connected to. Note that pose is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. Let's take the first example, right? So as you can see, we have a list here, right? So the tail of this linked list, as you can see, this -4 is made to connected to the node at index one, right? So this linked list has a cycle in it, right? So we are going to return true for this case because we can start from two and we can back to this where we started, right? We can back to this point. So we have since we there is a cycle, right? So how do we solve this problem, right? So to solve this problem, what we are going to do is we start from the head of the linked list, right? So what we are going to do is we are going to make or add all the nodes all the way to the int, all the nodes. We add them to a list, a set, right? For example, we add this node, the first node, for example, this node to a set. Let's say we have these three in our set, right? Then the next, when we are at this position, we add node to and instead of adding the node, we are going to add the value to the node in our set, right? Then we add two right here, and when we are here, we add zero to our set, and when we are at this position, we add four to this our set. We are adding instead of the values, because the values may not be unique, we are going to add the nodes, right? Because the nodes are going to be unique because their point the memory address they are going to point is going to be, or just the point is different, right? So they are different, so we are going to add the nodes in our set, right? So when we, as you can see, when we are at the tail of the linked list, we can traverse, we can uh, our next is gonna be the node at index one, right? So we can repeat this node, right? We can add it into our set. As this case, we have to check whether the node we are adding to our set is going to be, whether it was seen or not, right? So if it was seen, we can say like there was a cycle, right? So if we have already seen that node, we can say there is a cycle in the linked list, right? As you can see, two was already in the set, right? So we can say there was a cycle, right? So we can return right away true, right? There is a cycle at this case. So if there wasn't a cycle, we cannot see a node again, right? That's how we solve in this way. So let's take the next example, right? As you can see, let's say a node without a cycle. Let's create a node, right? Let's have a node. Let's say, well, I mean a linked list without a cycle. Let's say we have a linked list. Let's say this is two. The first node is gonna be one. Let's say we have a node three, right? We can have this node. As you can see in the pose, let's say the pose was p was pointing to -1. -1 means it's pointing to, our tail is going just pointing to none, right? So because there is no node at -1. So so this node is going to be, this linked list has no cycle, right? So if you add all of them into a link in SA, you will never reach to a case where you can see a node again. So in that case, we can return false. False. Yeah, there is no cycle in this linked list, right? But so this, as you can see, the time complex is gonna be off in, and the space complex is gonna be off in, right? But how do we solve this problem without using a space with only constant extra space, right? So to solve this problem, uh, we are now going to use a set, right? So to solve this problem, one thing we can do is we can just we can use two pointers, right? Let's say we have a slow pointer and let's say we have a fast pointer, right? So the thing is, like, if the faster pointer reach catches the slower pointer, that means there is a cycle in the linked list, right? So for example, we start from both of them start from the head of the linked list, right? So the faster pointer moves two steps at a time, and the slower pointer moves only one step at a time, right? Let's say the slower pointer is gonna be at this position, and the faster pointer is gonna be this position, right? It moves two steps, and when the slower pointer is at this position, the faster pointer is gonna be two steps, right? It moves from this position and moves two steps, right? Two steps means one is gonna be here, right? It's gonna be at this position. Two steps, right? So the head of it moves two steps, right? So whenever the slower pointer is gonna be at this position, the faster pointer is gonna be at this position, right? They will so the faster pointer is going to catch the slower pointer, right? They are going to point the same node, right? So as this case, we can say there is a cycle in the linked list, right? So there is a cycle in the linked list, so we can return just true, right? But if they will never reach, if the faster pointer never catches the slower pointer, we can say there is no cycle in our linked list, right? So I'm going to solve this problem this way. The time complexity is gonna be off in, and the space complexity is gonna be off on. So let's go to the implementation. So let's start first the slow, right? The slow is just the head, and the fast is also pointing the head in shadow. Both of them pointing to the head. So while the fast and as fast load next, if this is true, what we are going to do is a slow moves one step at a time, and fast moves two steps at a time. Fast is gonna be fast dot next two steps at a time. If slow is pointing the same node as the fast pointer, what we are going to say is there is a cycle we can return through at this point. Otherwise, if there was no way of finding a cycle, we can just return false, right? So there is no cycle in our linked list. So the time complexity is just often the size of the linked list, and space complexity is just of one, right? Because we didn't use any extra space. So let's see if this works for the given test cases. So as you can see, it passed for all of them. Let's submit it. So it passed for all of them. If you like this video, please subscribe. Thank you very much.